Hi there. In this short tutorial, I'm going to go through a number of options available to you under render settings using the Cycles render engine. So to begin with, note that I'm in Cycles render mode, which is this little button up here. You can see you can select other modes. This is all about cycles. To demonstrate the various things I'm going to do, I've got a very simple scene with a cube, a cylinder, and a sphere, and a background. And if I just go to rendered view, you can see I've also got a lamp in the scene, which is actually a sun lamp with the default settings, apart from the fact that I've brightened it up slightly. So we zoom in a little. So this is the preview render mode, which gives you slightly different results to the full render mode. A number of people have noticed that I've got a large number, a very, very large number down here under render samples. This is just because sometimes I let the render run until I'm happy with how far it's got, and then I can just stop it. In real life, of course, especially for an animation, you'd have a specific number in there. So let's set that to 25 now, which is the same as the previews. I'm actually going to return the previews down to 10. So let's turn preview render off and just press F12 to get a render. So there we go, and you can see it is slightly different, and obviously it's from the viewpoint of the camera. But we can see there's a fair bit of noise in there, especially if I zoom in a little bit. Now I'm rendering this at 50%, which is why it rendered quite quickly. If I turn this up a bit, it'll obviously be a higher resolution image and take a little bit longer to render, but we'll be able to see the noise a little better. So you can see it's rendering up there. You can also see how long it takes to render, how long it took to render the previous scene, and the peak memory usage, which is very important if you know you've got only a limited amount of memory available in, for example, your GPU or your graphics card. I'm rendering in GPU. In terms of the render itself, there's no difference between GPU and CPU. So you can see that's not too bad. One of the settings that I have by default switched off, and you may find is switched on, is the reflective and refractive caustics. So let's put this back to 50% just to speed things up and see what having those switched on does. And by default they are switched on. And bear in mind that, as I say, this is a simple scene. There's no reflective surfaces in here, they're all diffuse. In fact, they're all the default clay surface. So possibly it's marginally more noisy, but it isn't a significant effect. So let's give this a little bit more interest in terms of the surfaces. So I've opened a new window. I'm just going to quickly go to the node editor. We'll say new for materials. We've got the default diffuse there. I'm going to add simple mix shader and a glossy shader. We'll set it to my preferred method and plug that in there and turn the mix down a little, and then let's see what we've got under preview render. So you can now see we've got a bit of shininess on this ball now, and just to make it clearer I'm going to give it a bit of a colour and perhaps turn the roughness down a little and make sure that the glossy is at full. I'm going to come over to this cylinder, click new. I've removed the diffuse and I'm going to add a glossy shader only and just put that in. So this is going to simulate a metallic surface, and we'll give it a slight golden colour, and we'll turn the roughness down quite low. You can see it's a sort of golden cylinder with facets. And then over to our cube, and this time I'm going to use possibly the most troublesome of the shaders, which is the glass shader. Plug that into the surface. To be fair, probably the most troublesome shader is the volume shader, but I'm not going to cover volume shading in this tutorial. So by default it's got 1.45 for the index of refraction, which is appropriate for standard glass. And let's make it ever so slightly green. So if we now give that a render, and now we can start to see we're getting some strange noise artifacts here. Now it is only rendering at 25 samples, of course. You'll notice when you render you have slots here which allow you to compare one render to another. So I'm going to switch to slot 2 and I'm going to turn off reflective and refractive caustics and render again. So I haven't changed anything else. And immediately, even without comparing it, you can see that those bright spots have disappeared. See, there they are there. Now they actually are the beginnings of something which has a point. So if light's passing through particularly a curving object like the stem of a glass, you will get what's called caustics, which are little bright patches of light. If you imagine light bouncing off a reflective or passing through a refractive object, you do often get little bright areas, and these are the caustics. You'll also find that the apparent transparency of an object is significantly affected by whether caustics are on or off. So for some effects you will need them on, but for a great many of your renders you don't, and therefore I recommend turning them off. What it will do is it will mean you don't need to render as many samples to get an acceptable level of noise. So what else can we do? So we've got filter glossy. You'll almost always have glossy in some fashion in your scene. It may be a subtle element like this or a more gross element like that. The next thing that you might look at is clamping. So I'm talking mostly about noise at the moment. So I've got no clamp, direct or indirect at the moment. What this basically does is it reduces the tendency of one particular pixel to be a large amount different to the one next to it. So it's not blurring exactly, but in terms of brightness levels, it dampens it down. Direct meaning it's coming from a light source, indirect meaning it's bouncing off something. If you've got a very, very noisy scene, you may get some benefit from these clamp settings. Normally I set these to about 6. The idea is to stop dramatically different or bright dots, otherwise known as fireflies, from appearing in the scene, but they'll also reduce what you might call the dynamics of the scene, the range from black and white. For this scene, because the lamp is quite bright, it won't really make very much difference. But if you're having a lot of noise in your scene, try experimenting with those. Typically I'll use a clamp indirect of about 6. Indirect being light that's bounced off objects, direct being light that's coming from a light source. So going back to light paths, we have all these settings in here by default. These are basically the number of times that effectively light can bounce around or bounce off objects. So for transmission, this means that light can bounce around inside this cube, can have a transmissive bounce 64 times before Blender gives up on the light ever escaping into the camera. Glossy, obviously this is bouncing off glossy objects, and the default is 128. There's an overall bounces limit here, and then here we have transparency bounces. Works very much the same way as transmission. So a little bit about lights themselves. I bring up another window and go to the 3D viewport. Here is my lamp at the moment, and it's a simple sun lamp. I'm going to go to preview render down here so that we can see what's going on. Now, before I make any changes with the lamp, notice it's relatively slow to update, and that's because it's rendering everything. Even if I look through the camera, it's still rendering what's out here, even though it's showing me where the camera view is. We can stop Blender from rendering everything out here by just clicking Border here under Dimensions. Now you can see it's rendering quite a bit faster until we go outside the camera view, and then obviously it's rendering everything. So let's zoom in on part of the image, because I want to look at the shadows here. So we go to the light settings, you notice the size is 0.1 and the max bounce is 1024. What if we set the max bounces to 0? So effectively what happens is the light from this lamp will bounce off something, in actual fact not 0. So we get some slightly strange effects, but obviously it's not working properly. So let's put 1 in there. So the light will bounce off once, so it's bouncing off back here. One bounce, you can see our cube here has gone very dark. So if I start to increase, there you go, you can see we've now got a second bounce, and I'll increase it again and we've now got it brighter. And if we go, if you keep an eye on these things as well, this object particularly is showing more, it's probably showing more reflected from the cube, and as I go up, now you can see there's a reflection of that object. So I turn it off, we've just got black there, turn it on, and now we've got that object reflected. So you could argue I'm only up at 6 or 7 bounces there for this particular scene, and I'm getting everything rendered. So really, in terms of render performance, as well as in terms of noisiness, for this particular scene there's no need for a large number of bounces. Typically for any kind of realism you will need more than 6 bounces, and it will give you more subtle shadows as well. So if we talk about the shadows for a moment, we'll put the bounces up to 512, which is what I often use, and then we'll reduce the size of the sun lamp. So we go to 0.01, you can see we've got a much harder shadow now, and that stays the same all the way until we get down to 0 bounces. That's much more like a real sun on a sunny day. If I turn this up, we take it all the way to 1, it's like a very overcast day. So you can see there is shadowing, but it's much more subtle. And again, if I turn the bounces down, we've still got a blurriness to that shadow, but you notice things are going wrong at 0. But put it at 1 and it's sort of working. Again, we haven't got much going right over here, and we've certainly got a lot of noise here. But the main thing is obviously we've lost our reflections in here, so we need to turn that up. But again, as I say, a smaller number than the default is probably fine in there for most purposes, especially if you've got multiple lamps in the scene. And most commonly, the size is going to be something like 0.01, 0.015, something like that. So you get a bit of softness to the edges of the shadows without them being completely blurry, depending on what you're trying to simulate. So back to the render settings, which is what this video is really all about. We close light paths. There is a setting for volume sampling here, so if you have volumetrics, I'm not going to show volumetrics here, but the smaller the step size, the higher the resolution of the volumetrics, whereas most things you're calculating are a surface, volumetrics are three-dimensional, and therefore the effect on the time to render is multiplied. It's much greater, so a higher resolution volumetric will really slow your render down. Max steps is a bit like bounces in a transparent object. The smaller the max steps, the less calculation will take place until Blender gives up on the light beam ever escaping the volumetric. So a smaller number here will decrease your render time, though possibly not too significantly. A smaller number here will significantly increase your render time. Or you can decrease it obviously by increasing this number, but it means you'll get a coarser render for your volumetric. So under sampling, we talked about these clamp settings. We've got preview obviously, which relates to this preview render that we're looking at now, and the render itself, render setting, which you would normally have higher than preview render. There are a couple of different methods for rendering. There is path tracing and branched path tracing. I'll just turn off preview render, that's slowing things down. And really all this does is it gives you a method for independently controlling how much processing is put into the different aspects of a render. So for example, everything's equally weighted here, but we could put a lot more into glossy surfaces, for example, without putting extra into diffuse. So it allows you to more finely control where Blender puts most of its effort, if you like. So it can be useful, but it's quite a complex subject, and I very rarely use this myself. Motion blur, if you use this, the idea of it is that if there's movement in the scene, Blender will actually create two renders and then create a blurred version that is somewhere between those two renders, to simulate the motion blur you get in a real film camera when something is moving quickly. Under film, you can obviously adjust the exposure so that basically you can make it look more filmic by having a greater dynamic range. So in other words, the blacks are very black, the whites are very white, and you can adjust that here. And you can also set transparent, which means you can have a background wherever there's nothing in front of the camera, such as this background here. Blender will actually render to a transparency, an alpha texture, which means it makes it much easier to composite with other images or videos. Under performance, we have some options to control how Blender carries out the render. So threads is really all about CPU rendering. If you've got a quad-core processor, for example, then Blender can use 4 processors to do the calculation, and they'll work simultaneously. Normally you leave this on auto detect and Blender will find out how many processors you've got and use them accordingly. If you want to save some processing power for doing other things while Blender's working in the background, then you can set them to the number you want to use, which means your computer won't be completely locked up while Blender's doing its render. It doesn't really apply, as far as I know, to GPU rendering, which is what we should all use whenever we can. BVH is to do with geometry. You can see down here we can cache BVH. If there's a lot of geometry changing in your scene, things changing shape and so on, that's not going to help you very much because it's going to be changed every time. But if there's very little changing in your scene from a geometry standpoint, you may get some speed advantage if you're doing an animation in caching the BVH. In other words, you'll notice when you render that one of the first things Blender does is calculate that. So it calculates what the geometry is that the camera can see and uses that then for the render. By caching it, if it's not changing significantly, it can draw it back out of that cache rather than having to recalculate it again. I haven't found any massive improvements for using cached BVH, but obviously it will depend on your specific scene. A little bit about auto tile size. This came in, I think, in 2.74. If you're using CPU render and therefore you're using tiles, typically you want to use small tiles with CPU render so that however many cores you've got, you'll use all of them and allow them to thereby to optimize their parallel working. If you're using a GPU, it doesn't really matter too much. If you've got progressive refine on, as I have at the moment, it will just go and render the whole scene, whether you're using GPU or CPU. If we turn that off, and I now render with currently a tile size of 240 by 16, you can see Blender's running around rendering one at a time. And that's because I'm rendering with GPU at the moment, and I'll do it again and you can see it running around doing that. If I switch to CPU up here, then come back down, the progressive refine is off and I'm on CPU now, what you should see is 4 little boxes as the 4 cores that I have available are all used simultaneously. If I come down here, you can see that the tile size is actually much smaller, but you'll see that there will be 4 little boxes that are working simultaneously. And you can see that's much slower, but in terms of the render result, it's identical. Post-processing, what you're basically saying is run the compositor and run the sequencers after you've done a render. And dithering is for where there is a very subtle change in shade from one part of the scene to another, rather than just allowing, what you can get is aliasing lines, where you have a sudden change. Often get it with skies where there's slowly shading between a very light blue to a very dark blue. What you can do is set a dither amount here, and dither is really, it's just doing a pattern of dots to give you an intermediate shade. Alternatively, that leads us on now to output. What you can do is render at a higher bit depth. So the default is 8 bits, but what you can do is use 16 bits. So that's a very significant amount larger number of color variations for each color channel. If you're getting banding patterns appear, try switching to 16-bit. It will obviously use more memory, but it will often remove that banding effect. If you find it's still there, albeit perhaps the bands are thinner, then you may want to play with that dither setting. So now a little bit about the rest of the output settings. Whether you're doing an animation or a video, the final output is best placed into some kind of image file. So by that I mean you create even if it's for an animation, you create a string of images, very much like the images that an old world animator would have used, that they'd have created by pencil, that you then bring together, whether it's using Blender or Adobe Premiere, whatever software you want to use, compile them into your final video. The reason for doing that is because if Blender crashes or you want to stop Blender for a while, if you're creating image files, it's easy to do. You can restart Blender at the frame you want to restart at and off you go. If there's perhaps a glitch appears and one of the frames doesn't render properly for some reason, you can fix the problem and just re-render that 1 or 2 frames that were a problem. If you do that with a video file, I'm not going to say it's impossible, but it's much more challenging to fix video files than it is image files, even uncompressed video files. In terms of the formats that you can use, if it's a draft version of an animation or even a final image, you can use the JPEG. Typically, I think PNG is a pretty good compromise. It's a fairly large size format. It does have a certain amount of compression, but not an awful lot, and it produces pretty good quality results. If you really want the best formats you can get, then you may want to look at these here, things like OpenEXR. They are very, very large indeed, so make sure you've got plenty of space on your hard disk drive if you're going to create an animation in those. If you really are just doing a quick draft render, then you can obviously use these movie formats, or if you're rendering previously created animations or videos and you want to re-render them out to a video, then obviously you can use one of these formats here. And typically I think H.264 is a pretty good compromise. It's a format that's very compatible with YouTube and the compression isn't too bad, and you can control that compression. For standard images I tend to use PNG, but again obviously you can use larger formats if you want to. This is obviously black and white or RGB. Most of the time you're going to use RGB. RGBA includes some extra data that gives you the alpha channel, which is basically the transparency channel. You might want to use that if you're creating, for example, a frame to go round something else, so that you've got a transparency in the middle. And here you can set the amount of compression for the particular standard that you're using. If you tell Blender where to put its file and you give it a name, if it's an animation, Blender will put a sequence of numbers on the end of the file name to indicate which frame that relates to. Stamp just allows you to put some text onto your video or image, such that every image or frame has this stamp on it. And it may be just to record what your settings were or whatever, or it may be just to make sure it's marked as yours. So then we come up to the settings called dimensions. Obviously we can set the X and Y dimensions here. Typical HD video is at 1920 by 1080. You can very quickly reduce the size of the image you're going to create here with this percentage, so you can have it at 50%, or you can multiply it. So you could set this to 200% and it'd be a very high resolution render then. You can set the start and end frames. So we've got this sequencer here, and you can see that by default 1 is our start frame and 250 is our end frame, and we go in steps of 1, but we don't have to. We could go in steps of 10 if we want to. We might do that if we're going to create a very quick draft render, for example. Frame rate doesn't have too much of an impact if you're rendering out to individual frames, other than obviously the calculation of how far an object has moved between frames. Most commonly I use 25 frames a second, but you can obviously choose what suits the video you're creating. If you're going to overlay this on, say, a 30 frames a second live action video, then you will probably want to match the same frame rate to avoid any problems. You can remap time here, so you can make everything in the animation go slower or faster by adjusting these settings here. I'm not going to talk a lot about the freestyle elements at the moment because I haven't spent a lot of time working those out, but essentially this is a non-photorealistic render that allows you to have sort of cartoon effects and lines and things like that. Up until recently that was only available in Blender internal render, but now it's starting to appear in Cycles as well. Over here, this is basically how we want to render. If we click here, we will render to the viewport, the camera view. If we click here, Blender will do exactly the same thing for the frame we've told it to start on, which in this case is frame 1, but then it will increment the frame and it will do it again, and so on, outputting to whatever file or format that we've requested. Audio, I believe, means that you may have various audio files in, for example, a composition, and you want to just mix those together with whatever effects you've added out to an audio file, and you can do that here. To be honest with you, I think there are easier applications to use at the moment. You can display things in the image editor. You can display them full screen in a new window. Typically I use the image editor, so the render will appear in here, but if you say new window, a new window will open up, and that's where the render results will be. One little tip is this little lock here. If you lock the interface while you're rendering, that will allow a little bit of extra memory to the rendering process, so potentially avoiding problems of running out of memory and therefore having to use the hard disk drive, and may just make the render go a little bit faster. Obviously you can select between the GPU and the CPU, and if you're brave you can select experimental as well. So basically experimental is where early new features have been introduced. Very often that will be rendering options introduced into GPU rendering that haven't been fully tested and that are not available when you have the supported feature set. Because they haven't been fully tested, they come with a certain element of risk. You may crash, or Blender may crash when you're using those, or your whole computer may crash using those. So I tend not to use those unless I have to. A little bit about draft renders. If you've got an animation, so if I, for example, have my sphere here and press I and say location, then I come to the end of my scene and move my sphere over there, press I for location again. So I've now got an animation. What I might want to do is see how that animation looks without actually doing a proper render. So what I can do is come up to here and do an OpenGL render image. Looks pretty much as we're seeing it because by default Blender is using OpenGL to create the basic scene. But I can also create an OpenGL render animation, and that will use the settings over here to output an animation. For these sort of animations I very often would output directly to a small video file, and that just gives you a view of how the animation looks without actually doing the proper rendering. So the next thing you might want to do, especially when doing preview renders, is turn on shading. So if we go to metcap shading, for example, we can turn on a number of options. So for example, we can turn on depth of field. So depth of field is something that appears in the camera and obviously means that the camera has a specific focal length and anything in front of or behind that focal length is out of focus. But this allows us to have a very quick view on where that depth of field is. So if I come out of here and bring my camera up and I tell it to focus on the sphere, and now you can see the depth of field it's now in focus there. And by turning the viewport f-stop down, so this is the viewport f-stop, not the rendered one, you can see we're now getting that effect back where parts of the scene now are in focus and parts of them aren't. So it just helps you see where the depth of field and where the focus is. And ambient occlusion is just a method for simulating how light can be absorbed more where two objects are in close proximity. And you can choose different shading options for your metcap. So here's a metallic one. You have a weird one like this, which obviously might be of some use to you because it relates to the direction of the normals and so on. So there's a number of different options you can select here that might just help to simulate what you're looking for. So finally, in terms of rendering, we have the render layer. If we click this, we see the passes, and by default it's what's called a combined pass and a Z pass. So that means if we were to look at the node editor and we click here, which is the compositing node editor, and click use nodes, here is our render layer, here is our compositor. If I press F12 now, so you can see that this object is in focus. I left the depth of field switched on and these are out of focus. And you can see a miniature version of the scene here. And we've got data coming out of Z, which tells us how far away from the camera any particular part of the scene is, which we can use for creating mist and so on. You can do a mist pass, which is very similar, but you need to switch it on to do that. So if you need mist data, then you need the mist pass to be switched on when you do it. And now you can see how an object that's close is very dark and one that's further away is very light. So just as we're here, very quickly, I could do something such as a color mix node. I can put the mist in the control of that color mix node. I can put the image into one side, put it in that side, and the white in the other. And we'll just say screen. And then we take the output here. And if we set that to mix, and then we set this to some darker level, you can see we've got the beginnings of a mist effect, especially if we use screen. But you may find the mist, and particularly Z passes, are effectively producing data that's quite large and therefore not immediately suitable to mix in that way. So you may need to add a math node, set to multiply, and there we go. You can see it starting to whiten out anything beyond a certain point. Z works in a similar fashion, but is numbers that are much bigger. So you can see I've had to multiply that down quite a bit. And then you can add color ramp so that you can have things that are quite close, very visible indeed. It's not the best scene for demonstrating this, but you can see that's a very quick way to add some mist to your scene. If you need to use object indices, which I've shown in other renders, again, you'll need to turn them on here. And there are a multitude of options here in terms of what elements of the scene will be included in a given render layer. And of course, you can have multiple render layers and give them different names as you go. And I've shown how to use this in several other tutorials recently. One last thing, if you're rendering an animation, you will have a certain amount of noise, no matter what you do to remove it. And if you just use the default settings, it will be as if these speckles are almost like a screen and the animation is taking place beneath it. So it doesn't look quite right. You can get away with more noise by having the seed for the noise different for every frame. And to do that, just click in here and type hash frame, not in capitals, and then the seed should be set, it'll turn purple and the seed should set to the frame number. And you can see it changes for every frame, which will mean this pattern of dots will still be there, but it'll be a different pattern for every single frame. So it'll sort of blur in your eye and be a lot less noticeable. So I hope you found that useful. If you did, let me know. I'm always interested in suggestions, and this tutorial was actually suggested by a viewer as well. If you enjoyed this tutorial, don't forget to click subscribe and like, and I'll see you in the next tutorial. Thanks a lot.